The second kind of loop is a for loop. And it's a special kind of loop that iterates through a predetermined number of values. And those values are defined by an array. So a for loop is going to contain what's called a loop index variable. So we don't have a loop control variable anymore. We have a loop index variable. Typical names for a loop index variable, I, j, k, m, n. You'll see those commonly for a for loop. Our loop index variable is a scalar value that's going to change value every single time we pass through the loop. So every single iteration, it's going to have a different number according to values in an array. And the for loop will continue to repeat the code until there are no more values left in an array. So this is what a for loop looks like. For index, or I, j, k, whatever, typically you'll see me write I. For I equals an array of values. So it's important to note that this is not assignment in our traditional sense. It's not saying that I equals this entire array. It means that I equals each of these values in the array one at a time. So our index is a scalar number that's going to change. It's going to grab each of these values one at a time, use those in the code until it runs out of values. So it's going to execute, the number of iterations is going to be equal to the number of values in the array. So common misconception, it is a scalar value. So let's go ahead and look at an example. So here I have an example for loop. So I've got some code that wraps around it, and what I'm gonna do in this code is I'm illustrating what's happening when we do element by element operations. So let's say x equals 1 to 6, and I wanna calculate 3x squared plus the square root of x minus 15. We can easily do that with element by element operations. We would just say y equals 3 dot times x, the quantity squared, plus square root of x minus 15. What's happening behind the scenes is really a loop, that's initializing y with a bunch of zeros. So here we go, let's run our code, see what happens. So initializing y with a bunch of zeros, and then it's creating a for loop where I goes from 1 to the length of x. So the length of x is 6, so I is going to be 1, 2, 3, 4, 5, 6. This is common syntax. I equals 1 to the length of something or the size of something. So I starts out with a value of 1. So now I is 1. You can see over here in my workspace, I is 1. It's the first number in my array. So here I'm saying, in the first location of y, take the first number in x, multiply it by 3, square it, plus the square root of the first number of x, minus 15. So here if I display the results now, whoops, forgot to transpose my array. So if I display, no. X is a row. What? Ah, they're not stacked on top of each other. There we go. Sorry about that. So when I print out my results, x is 1 through 6 here. And then I've calculated the first number in y. Okay, so now I keep going. I is now a value of 2. So notice I is 2. It's my second number in this array. So I'm saying for the second number in y, calculate 3 times the second number in x squared plus the square root of the second number in x minus 15. So now when I display results, now the second number in y is calculated. And then I keep going back up. I is now 3 because this array looks like this. 1, 2, 3, 4, 5, 6. So now it's 3. It's the third time through my array, so it's the third number. I calculate my y value, and now you can see my third value in y is calculated. And then I keep going up. I is now 4. You can see in my workspace, I is a scalar. It's now the fourth number in my array. And I keep going, so now the fourth number in y is calculated. Then I is 5, and then I is 6. So that now I have all of my values in y calculated. So MATLAB's really nice because it allows us to do all of these calculations with just one line of code, but this is what's happening behind the scenes. We have a for loop where I equals 1 to the length of x, where I'm calculating each value in y individually, but it's all happening behind the scenes. So I is a scalar, that's first 1, then 2, then 3, then 4, then 5, then 6. It executes all the code inside, given each of those numbers one at a time, and then when it runs out of numbers, like it just did, it exits, and it's done.